Okay, I'm going to go ahead and go over these. Alright. So the easy says, what's the greatest common prime factor of 32 and 28? So this is it's combining two concepts, greatest common factor and prime numbers. If you list the factors of 32 and 28, the factors of 32 would be 1 and 32. And when you're doing this, the best way to start is to have kind of a system. So I always start with 1 and I work my way up. 2 and 16. 3 doesn't go into 32. 4 and 8. 5 doesn't go into 32. 6 doesn't go into 32. 7 doesn't go into 32. 8 does, but 8's already on my list. And once you start repeating, you know you have a complete list. So then if I do the same thing with 28... those are the factors that I get. So if you look at the common factors, there aren't very many. The greatest prime factor, there's only one factor on here that's prime, and that's the 2. Remember, 1's not a prime, and 4's the greatest common factor, but it's not prime. Right, because 4 has factors other than 1 in itself. So the greatest common prime factor is 2. How'd y'all do on that one? Yeah. 4 is a gotcha answer because you're just skipping over the word prime. And you're just looking at greatest common factor. But greatest common prime factor has to be a prime number. And 4 is not prime. Alright, so sometimes easy is deceptive because it's kind of, if you read the problem correctly, then it's easy, but if you didn't, then it's hard. Okay, this one, it's a little deceiving. There's really only, you can really right away narrow it down to 2 answer choices. It says, if x is a positive integer greater than 1, and x times x plus 4 is odd, then x must be. The answer choice has to be A or B. And the reason is you have to kind of use a little bit of logic. All numbers are either even or odd. So when I pick a number for x, I have to pick a number that is either even or odd. I'm not going to be able to eliminate both of those answer choices because there's no way for a number to not be even or odd. It's got to be one or the other. So any number that I pick has to be one of those two. So right away, these other 3 are a waste of my time. I'm going to pick an even number, I'm going to pick an odd number, I'm going to plug it in and see which one makes this odd. So the easiest 2 numbers to pick would be 2 and 1 or 3. We don't typically like to pick 1, so I'm going to pick 3. If I plug in 2, 2 times 2 plus 4 is 12, which is not odd. So it's not A. Okay, if you plug in 3, 3 times 7 is 21. That's odd. So it has to be this. Okay. The other 3, it might be a prime number. It doesn't have to be. We could keep going. 9 is odd but not prime, and 9 would work. A factor of 8, it doesn't have to be a factor of 8. 3 worked, and 3 was not a factor of 8. It doesn't have to be divisible by 8. 3 worked. So even if you didn't recognize that A and B are the only 2 that would work, if you plug in several prime numbers, you'll get prime numbers that don't work in this. I mean, you'll get numbers that aren't prime that don't work. In fact, we plugged in 2, and 2 was prime, and it didn't work. And then factors of 8 and divisible by 8 also work. But that one, if you use a little bit of logic right away, it has to be A or B. All numbers have to be even or odd. So whatever I pick for x has to be one of those 2. Okay. The last one is hard. This is saying that if you were to figure out 2 to the 33rd power, of course I can. Okay. So 2 to the 33rd power. Okay, with the new calculators, this problem is really not as hard as it used to be. With the old calculators, it would not show you 2 to the 33rd. That was too many digits. And so it would show you like 8.589 times 10 to the whatever. It wouldn't show you the units digit. With these new calculators, they probably wouldn't ask you one like this. They'd probably have to ask you one where it was a much larger power of 2. Oh, no, it would still do it. So they probably wouldn't ask a question like this again, just because the new calculators have made a question like this obsolete. But just to kind of show you, let's say that your calculator, you're using an 84 calculator instead of an Inspire. It will not show you the full length of 2 to the 33rd. So this is asking you what's the units digit of 2 to the 33rd, and how much less is that than the hundredths digit of 567 over 1,000. Okay, so 567 over 1,000 is 0.567. So what's the hundredths digit of that? We'll start with that because that's easy. So this is tenths hundredths. So that's 6, right? The hundredths digit of 567 over 1,000 is 6. Okay. Now, to figure out the units digit of 2 to the 33rd, there's actually a pattern to the powers of 2, to any powers. Alright, so here's the pattern. And we only care about the units digit. 2 to the first, the units digit is 2. 2 to the second, it's 4. 2 to the third, it's 8. 2 to the fourth, it's 16. It's 6. Right, the units digit is 6. What happens when I do 2 to the fifth? I get 32, which has a units digit of 2. When I do 2 to the sixth, units digit is 4. 2 to the seventh, my units digit is 8. 2 to the eighth, my units digit is 6. 2486, 2486. There's a pattern in the units digits for powers of 2, for powers of any number. So in this case, they repeat every 4 powers. If it's a multiple of 4 in the exponent, then the units digit is 6. So what's the closest multiple of 4 to 33? Right, if you look at the power, all the multiples of 4 are going to end in 6. Well, this is 1 more than 32, right? So this would be like if you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All the way up, you would land on 32 right here, because 32 is a multiple of 4. So where would 33 be? Back up here. 2 to the 33rd would have a units digit of 2, which the calculator nowadays will show you that the units digit of 2 to the 33rd is 2. Okay, kind of hard to see, but it is 2. So the difference between those is 4. Okay. Used to be a hard problem because you couldn't get the units digit from the calculator, so you had to know to look for a pattern. Now this would be an easy problem because the calculator would give you the units digit. You just would have to know the terminology, units digit and hundredths digit. So they might still ask something like this, but it wouldn't be hard. Okay, so the next thing we're going to look at divisibility. Okay, divisible means divisible evenly with no remainder. So for example, 16